Okay, for mini project 2, we're going to have you look at clustering movies based on user reviews. One of the common areas where clustering is sometimes used is like grouping customers or um, product together into different groups, so you can see that. So let's look a little bit of this. Again, we're going to import our standard libraries here, and we're going to use a set of data called the movie lens data set. This is a well known set of movie data. It comes in lots of different formats. So here's actually the Movie Lens website. They have some huge data sets with 250 review ratings for this, and then they have smaller ones with only 100,000. So again, the 25 million ratings would just be a little bit too big for us. So we're going to stick to some of these smaller values with only 100,000 ratings. So we're going to read that in. That might take a little bit to read in, but here's what we get. We get a list of movie IDs, the title of the movie and the genre, and then we get the actual ratings for each movie as a separate file. So the ratings are 0, meaning no rating, 1 or 2, they're basically stars, 1 or 2 stars, up to 5 stars being a positive rating. But we're going to convert that to an adjusted version of that, because again, having 0, not rating it, it puts it at 0. It means you really didn't like it, and so we're going to try to switch that around so that poor ratings are between -10 and -1. Neutral ratings are in the middle. If you had no rating, it's also in the middle, and then positive ratings are from +1 to +10. So it gets away from this problem where if you didn't rate the movie, it's equivalent to rating it really poorly with this. So we're going to do this rating adjustment methods and look at these ratings here. So here's a movie, here's original rating, and here's its adjusted values for these areas. So to make this a little more meaningful, we're going to try to create a matrix of these movies, and let's see how that works. So okay, fix my little error here. Okay, so here's we're going to use what is called a pivot table function here. We're not going to go over how that works, but it converts our data. So here's our data now. We have each movie and each user, and anytime a user reviewed a movie, we'll have its score in here. The rest of these are not a number, meaning the user did not review that movie for this. So we see the reviews for all of the users on all the movies. These not a number things are going to be a problem, so we're going to fill those in with zeros, and so this is the matrix we end up with. So if a user didn't review a movie, it gets a 0, and then if they did, we just get the score of that movie, and again that value now ranges from -10 to +10 for these. Now this is a large data set. Again, we've got lots of different movies in here, almost 700 movies, and lots of different users here. So we're going to use principal component analysis to reduce the number of columns rather than doing looking at all 700 columns. We're just going to look at a set of them, and so in this case we're going to use principal component analysis and reduce this to 20 components. So, and then we're going to do clustering on this. I'm going to skip over this right up for now, and we're just going to do clustering. And again, you have to figure out how many clusters you want to have for that, and then we'll do some analysis of those clusters. So what do we want you to do as far as this mini project goes? We want you to analyze it and try to determine how many clusters you should be using putting the movies in. Again, we don't know. There's no short answer. I mean, you might think, oh, there's only 5 categories of movies: action movies, romantic comedies, science fiction, horror. I don't know. But are those appropriate clusters, or how do we actually cluster it? Is it better to have 20 different clusters of these movies based on, so I guess the goal is to have clusters where if a user liked one movie in a cluster, the user might like another movie in that same cluster, and we group the movies together. So Now, I'll just warn you that this, how this is actually done is with movies is a little more complicated than this. But again, this just shows you a nice simple use of clustering for this. Um, so in your write-up, you're going to want to address three different questions. One is the number of clusters. What do you think is a good number of clusters for this movie, and how do you come to that conclusion? So maybe write a paragraph of that. Then talk a little bit about principal component analysis, whether or not you think that is useful or not. So again, up here, we're doing principal component analysis. If we want to just skip that, we could just comment out this line, and we would not overwrite the movie pilot with the new reduced version of the movie pilot. You can also just change the number of components with that. So do you think principal component analysis is useful for this? And then also sparse matrix issues. One of the things is that we have all these zeros in here, and is this causing any problems treating all these numbers, converting this data? It's okay to have all these zeros in this. So again, some of these are certainly open questions, and I don't expect great answers. I just want you to at least think about them a little bit and give a quick your opinion on them. The main thing I want you to do is this number of clusters, analyzing that. So we have give you some tools for that. So once we've done our analysis here we're doing it with 20 clusters. We can do things like we can print out a histogram, and so this shows how many movies are in each of the clusters. So you can see there's some clusters very few movies, and there's this one cluster with 6,000 movies in it. So you can also display, you can select any of these clusters and you can display the movies in the cluster. So here we got Money Train, The Swan Princess, Eddie, Multiplicity. So again, one warning is most of these movies are from the 90s, so just remember that. So maybe you can kind of look through some of these clusters, and again, I could switch this to look at a different cluster. Go to cluster 5 and see what's in that cluster. And then just get some ideas. Are these the movies that are in, do I think Bring It On and Rocky 2 and Doolittle, Dr. Doolittle 2, if someone liked one of those, they'd like all of them. So how am I doing there? We can do some plots. We can plot the categories of movies by the first two principal components there. But more important maybe is this elbow plot and the silhouette analysis. We can look at a whole bunch of different clusters and measure the inertia at each one and print that off here. Now I'll just warn you, we're working with larger data sets, so this elbow plot stuff will take a little while to work out. So where do you think the elbow is in this curve? Similarly, you can run the silhouette analysis, and again, this will take a long time depending again on how many values you're testing out here. And then you can look at the silhouette analysis and see what do you think are some good values for that. So that is your goal of here. Oops, I still have this task 3. Let me delete that. Okay, so that's your goal, basically to look through this data, which is a more real-world version of some data, and try to figure out how many clusters do you think would be a good number of clusters for this. Dimensional reductions is PCA helping. You might want to run it with or without PCA stuff. And then just think about, what does this mean? Is there a better way to organize this data rather than a matrix where each user in each movie is set up like this? Is there a better way of categorizing that data? And I'll just, yeah, there are better ways, and we're not going to go with it. It's beyond the scope of this course, but that's why I just want you to start thinking that one of the reasons this whole process will not work very well is because of all these zeros that we have in this matrix. So, okay, hope you enjoy playing with this and playing with some real world data.